It is easy to understand why so many of us find inspiration from looking up at the night sky. I, in fact, built a career out of it. But it might surprise you to learn that we are losing our ability to connect with views of the night sky every year. So, that connection is something that I want to talk about today, the connection between the past and the present, the connection between science and the arts, the connection between each other as we grapple with knowing that we exist together on this gigantic rock floating through space with no evidence of any other life out there. It's important for us to talk about that. This story starts at Yerkes Observatory. This is the Milky Way. You can actually see the Milky Way from here in southern Wisconsin from this whole historic observatory. Yerkes Observatory was founded in 1897, and when it was founded, it had the largest telescope in the world. You can see from this beautiful building that there are multiple domes, so there are lots of telescopes there. It was founded not as the idea of just having a telescope, but as a source of innovation, exploration, experimentation. There are laboratories, there's a machine shop, there's dark rooms, there are multiple telescopes. Astronomers and engineers came together to really innovate and ask some of the biggest questions in astrophysics at the time. This is what the biggest refracting telescope in the world looks like today. It continues to be the largest refracting telescope where light gets collected through a lens instead of a mirror. It's fully functioning, and my favorite part about it is that we don't have computers set up to it. So you actually move the 8-ton huge tube with your hands because it's so perfectly balanced. In the same way that Mary Calvert here on the right did when she was at Yerkes in the early part of the 1900s. Astronomers like Edwin Hubble, Gerard Kuiper, Chandrasekhar, who went on to win a Nobel Prize, Carl Sagan, all studied at Yerkes over its existence. So Mary Calvert, you can see here that she's looking through the telescope. And you can imagine that astronomy was studied for most of its history by looking through, seeing an image and having to remember it, or maybe sketch a picture of it so you can remember, so you can look at it again later. At Yerkes, what happened when it was founded is that we started to refine the process for how you capture an image that you can take with you as data. We capture these images on glass plates. This is an example of a glass plate that's in the Yerkes collection. So there was a company called Kodak Eastman that actually was quite near here, by near Yerkes Observatory. So the astronomers and the engineers at Kodak Eastman got together to refine the emulsion that you put on a glass plate because it had sensitivity to darkness. And then the darkroom process for exposing, for developing, these techniques were just being started to being applied. And you can remember the photographs where everyone kind of had to stand very stiff because that's how you collected photographs at this time. The collaboration, the connection between these two companies, engineers and astronomer, skyrocketed, sorry for the pun, our ability to capture the sensitivity of astronomical images. So modern astrophysics was really launched from Yerkes at this time because of our ability to collect data, to measure more accurately the brightness of objects, the position of objects, to take our data and hand it to our collaborators around the world so that they could evaluate it. Now, one of the things that I'm doing here at Yerkes now is taking that idea of bringing together the connection from different fields together again. Yerkes is now operated since 2020 as a nonprofit, so it's not affiliated with an academic institution. And one of the things we're trying to do, in addition to reinvent what astronomy looks like at a historic facility with our education program, but also connecting science and the arts. And so we have developed a program where we bring in artists and we have residencies for artists. And this is an example of one of the collaborations that I had with artist Ashley Zielinski. She was listening and trying to understand some of the things that had been discovered and really studied at Yerkes and part of its legacy, and interpreting that as some sort of artistic expression. Her medium was sculpture. And so this is called Time Will Tell. It's a marble sculpture that talks about the existence of curvature of space-time. And for me as the scientist to be able to kind of peel back the complexity of something like that and make it have meaning in a way that an artist can interpret it is a very humbling experience. And it just really makes it mean a lot more. What does it mean when I'm kind of studying these complex topics? Another example of artists that we have in residency are musicians. So this is a group called Eighth Blackbird, and they have been hosting creative labs at the observatory for the last couple summers where they bring contemporary classical musicians, professionals, and students who are composing works while they're at the observatory, feeling the legacy, the beauty of the architecture, understanding the physics and the astronomy, and then performing them in these spaces, which is not necessarily easy because it's a gigantic dome with echoes and things like that. So, taking this kind of modern interpretation of the legacy that we have at Yerkes has meaning. This is another example of a person who has come and studied at Yerkes. This is Nancy Grace Roman. She's standing in front of the telescope in the 1950s, moving it by hand and doing the same sort of analysis we do today. She went on from her role at Yerkes to become NASA's very first chief of astronomy. And because of the work that she did in that role, bringing scientists and engineers together to determine whether or not we could launch a telescope into space, they are actually naming the next big telescope after her. So you'll hear her name a lot more next year when NASA launches the Nancy Grace Roman Space Telescope. Now, modern technology is amazing. It is such a huge tool. And the Space Telescope is not the only kind. So I want to introduce you to a modern telescope called the Vera Rubin Observatory. This telescope just opened its eyes to the universe earlier this year. Its technology is kind of amazing. It's an 8-meter mirror, and then at the top where those two circles are, there's a digital camera that's about the size of a minivan, and it's the largest digital camera that was ever built. And its entire purpose is to sit on the edge of this telescope and explore the universe. This is what the dome looks like. It lives in the Andes of Chile. And this is one of the very first images that it has captured. 2 beautiful spiral galaxies, and every single speck that you see in that image around it are each individual galaxies, each with hundreds of billions of stars. And this is a teeny tiny snapshot of the universe that Rubin will study. But it's not even the most exciting from my perspective. So what Rubin is going to be doing is it will be looking at the entire sky over and over every few nights. And in doing that, it builds up a template of what the sky looks like. And then when it takes another view, you subtract the template, and everything that's left is everything that changed. So if it got brighter or fainter or appeared or disappeared or moved. And beyond that, the promise of this facility is that they will send out an alert to the world within 1 minute of observation for everything that changed. They are estimating when they start this survey that they will be sending out 10 million alerts per night. This is not computing capacity that we could have imagined 10, 20 years ago. This is something that we have to do right now with our technological ability. It's an amazing tool. They will be looking at the sky for 10 years. And so we get this detailed video of the universe of 10 years of time, looking at how things change in a way that we have never been able to study before. How does that connect to the past, though? Now, you remember I told you about these glass plates. At Yerkes, we have 180,000 glass plates that are images captured between about the 1890s and the 1980s. This one in the middle is one of my favorites. It's from 1909. It's the Andromeda Galaxy. And if you zoom in, you can see details of all the individual stars in there. So what we're in the process of doing is trying to digitize these glass plates, figuring out how to take the physical historical object, digitize them so that we can analyze them with modern software tools that astronomers use. One of my favorite parts about this project is being able to bring in undergraduate interns. So every summer, my team is able to welcome a group of interns who come. Not only can they get their hands on the glass plates, learn how to digitize them and analyze them with modern tools, they also get to use the other telescopes that are in the facility that are great for research. We have a 1-meter reflecting telescope. So they get their hands on a working modern telescope, and they can compare what certain objects looked like over a timeline of 130 years. And this is not anything that we've been able to do before. We can look at how stars move in globular clusters and how planetary nebula expand over that period. And it's not very often that in astronomy you get to see things change in a human lifetime, because usually they're changing on the order of millions or billions of years. So these students get to do that, and not only are they learning these modern techniques from a historic observatory, they get to interact with the artists that we bring in every summer. So they get to work and talk about what the science is at its core and what it means. Why are we doing it? Why is it important? Why does it matter? And to see them experience such joy, experience such connection while they're learning these very technical things that can, they're fabulous tools, but it can be very dry. To bring in the humanity of these projects as part of their work at Yerkes, and then take that out into the world with them as they start their careers, wherever they decide to go, is one of the most rewarding parts that I've had in my work with these students. So my hope for us all is that we can take the time to connect with the universe, to go out and sit in our backyards and look up. The sun has been giving us miraculous aurora lately, so if you've had a chance to see that, or even look for the 3 stars that make Orion's belt in the northern hemisphere in the winter. You don't need a telescope or binoculars. What you can do is make sure that you spend at least 10 minutes. Put your phone away. Just look. As soon as you look at your phone, you ruin your eyes' ability to see faint light. And so let your eyes get dark adapted and you start to see more and more faint stars. But unfortunately, this is a map of what the United States currently looks like at night. All of those bright spots are artificial light. Those are the lights that humans have produced in cities. You can see the West Coast. You can see the outline of Lake Michigan from Chicago straight up to Milwaukee. We're making it harder and harder for ourselves to be able to see those stars. In a lot of these cities, you can only see maybe the brightest stars and the moon, even if you stand out for 10 minutes to try to let yourselves get dark adapted. It's so bad that right now, every single year, the amount of light pollution that exists from humans is increasing by 10%. Every year. 80% of the people in the world cannot see more than the moon or a couple stars in the sky. So we're missing that connection, that human ability to understand or just reflect on our place in the universe and the way that generations and generations of people before us have just gone outside and done. It was part of their existence to kind of sit back and really think about that. But the good news is that we can do something about it. We can turn our lights off outside if we don't need them. We can decrease the amount of lights that we have. You can put in warm bulbs instead of the bright blue bulbs. It not only helps us, it helps the birds, migration patterns, the entire ecology, all of those little gnats that you think are kind of annoying when they're in the light. Well, it's annoying for them too, because they think that's the sun and it's not. It helps pollinators understand where they're supposed to go and when they're supposed to do their work. So it's not only our connection, it's actually Earth's connection to supply itself with the nutrients it needs. This picture kind of represents something. I mean, I can't tell you quantitatively the benefit of turning your lights off outside, or that connection that you might have to the night sky, or 2 generations from now if those kids don't have the ability to look out. This is my daughter, who graciously slept on my chest when I was giving a keynote talk when she was 3 months old. She's 10 now, and I would have loved her to be here, but she's sick today. And one of the ways that this connected me to her and connected me to the audience in that moment is that I asked the moderator that instead of clapping at the end of my talk, if everybody could wave their hands so as not to disturb the sleeping baby. And they did it, and it was memorable, and I still run across people in my field who say, I was at that talk. And so the connection of doing that is kind of, the benefit of it is summarized in this quote that this photo shows behind me from Albert Einstein that says, not everything that can be counted counts, and not everything that counts can be counted. So what I hope for you is that you seek out those connections that for you and your life count. Thank you.